Okay, another second derivative. So, before you can do a second derivative, you need a first derivative. And for us, that's df dx equals, this is a quotient, so the quotient rule goes off. Bottom times derivative of the top, which is 1/2 x to the minus 1/2. I didn't bother replacing root x with x to the half. I take it you've seen that trick enough by now to anticipate it. So that's bottom d top minus top d bottom. The derivative of x plus 3 is simply 1, which is nice, all over the bottom squared. Now, if I multiply this out, this 1/2 x to the minus 1/2 goes through both of those terms, and we get 1/2 x to the positive 1/2, because you add powers here. 1 plus negative 1/2 is plus 1/2. And then we get 3 over 2 x to the minus 1/2. And then we have minus x to the 1/2. All over x plus 3 squared. Now these are like terms. This is 1/2 x to the 1/2 root x minus an entire root x. So when you subtract those, you get minus 1/2 x to the 1/2 plus 3 over 2 x to the minus 1/2 all over x plus 3 all squared. The fractions are not great. I think I'm going to double the top and bottom to get those fractions out of there. So if you double the top and bottom, you get minus x to the 1/2 plus 3 x to the minus 1/2, and we end up with a 2 in the denominator, so 2x plus 3 all squared. I think that's about as nice as we can make that first derivative look. And yes, that's only the first derivative, so now we have to do the derivative of this, and the ugly will go up a little more. Let's see what happens. So, our second derivative, d squared y over dx squared, will be bottom times derivative of the top, which is going to be minus 1/2 x to the minus 3 over 2 plus, or sorry, it starts out as plus, but then minus 1/2 comes down, so minus 3 over 2 x to the minus 3 over 2. Okay, so all this was bottom times derivative of the top. Now, that's minus the top times derivative of the bottom, which will be 2 times, or sorry, 2 times 2 is 4, x plus 3 to the 1, and then the derivative of x plus 3 is just 1, so that didn't really change anything. All this is our numerator, and it's all over the bottom squared, which would be 4x plus 3 to the 4th. We could stop there, and it's awful tempting to, but let me see if I can clean this up at all. One minor good thing happens here. This 2 we could distribute through the brackets here, and it will cancel both of those fractions. That makes things 1% less terrible. We get x plus 3 all squared times minus x to the minus 3 over 2 minus 3 x to the minus 3 over 2. Those are like terms. We'll be combining those in a moment. Okay, and then for our second term, we have minus 4. There's the minus, there's the 4. We have an x plus 3. And then we have this piece, which I hope I can write small enough. Minus x to the half. And plus 3x to the minus 1 half. And all that is over 4x plus 3 to the 4th. See anything else we can do? Both of these terms contain x plus 3's. We could divide one of those out. That would be a small improvement. We could distribute this minus 4 through that set of brackets. And there may not be too much else. But let's do those steps at least. If we divide everything by x plus 3, one of these x plus 3's goes. There's still one left. And then we have minus x to the minus 3 over 2 minus... Oh, I'm sorry, I said I was going to combine these and almost forgot. This is minus 1 of this thing, and then minus 3 more of this thing, total of minus 4. X to the minus 3 over 2. And I feel like that minus 4 should be out front, but I might just leave it there rather than copy out this whole thing again. And in our next term, we have a minus 4. The x plus 3 got divided out, and what remains is minus x to the half plus 3x to the minus half. All over 4, and we still have x plus 3's down here, but we divided one of them out, so only 3 remain. What else could we get away with here? We could factor out a minus 4. There's minus 4's in both of these, so I'm going to do one more step. Minus 4 comes out and leaves x plus 3 and x to the minus 3 over 2. From this next term, minus 4 divided by minus 4 is just plus 1, and then we get negative x to the half and 3x to the minus half. And all that is over 4x plus 3 cubed. And one last thing, 4 over 4, we can cancel those out. So that 4 disappears, so does that. There might be ways to simplify this a tiny bit more. In fact, I'm afraid I just noticed one. You could distribute this through and then you get a like term and so on, but I think that's all the space that I have, so let's say this is our second derivative, give or take a little more polishing. The important thing is you got the idea that you can take the derivative using the quotient rule and then take the derivative again using the quotient rule and get your second derivative.